Okay, if you remember last time we defined the six hyperbolic functions. The six hyperbolic functions, we have six hyperbolic functions. The first one of them is called hyperbolic sine of x, hyperbolic sine of x. And we said this is by definition is e to the power x minus e to the power minus x over 2. And we have the hyperbolic cosine of x. We define it to be equal to e to the power x plus e to the power minus x over 2. And the reciprocals of these, the reciprocal of hyperbolic sine will be called hyperbolic cosecant, and the hyperbolic of cosine will be called hyperbolic of secant. Similarly, we have hyperbolic tangent of x, which is equal to the sine hyperbolic over cosine hyperbolic. That is e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. We discuss how to evaluate these functions, the graph of each one of them. For example, we found that the graph of hyperbolic sine is similar to it's like x cubed, something like this. This is the graph of hyperbolic sine passing through the origin. We found also the graph of hyperbolic cosine to be similar to a parabola. It's not a parabola, but it is similar in shape of y equal to x squared plus 1, for example, something like this. And we found also that the tangent hyperbolic function has two horizontal asymptotes. And in the shape, it is similar to tangent inverse, but here we have y equal to 1, y equal to minus 1. Then we said, okay, we have some identities for these functions need to be discussed. So I listed some of them here. Of course, the purpose of the section is not to study in details these functions, but we will study only the derivative and some basic identities together with the definition of these hyperbolic functions. The first two, the number 1 and number 5, I mean, hyperbolic sine of minus x equal to minus hyperbolic sine of x. So in this case, we say that the hyperbolic sine is an odd function. The hyperbolic cosine is an even function. And you remember these two identities agree with the identities we have in trigonometry. The trigonometric functions sine and cosine. One of them is odd, which is the sine one, and the cosine is an even function. So they have similar properties like the trigonometric functions. Now coming to the second one, cosine hyperbolic squared minus sine hyperbolic squared equal to 1. This is called the hyperbolic identity. And it is the very famous identity in hyperbolic functions. And last time I told you that this is why we call these functions hyperbolic, because it satisfies the hyperbolic equation or the hyperbola equation. Similarly, we have number 6, number 3, 4, and etc. We have the sum of two angles. If you remember, for trigonometric functions, sine x plus y is sine x cosine y plus cosine x sine y, which is exactly the same for hyperbolic. But for the hyperbolic cosine, in the trigonometry, we have cosine cosine minus sine sine. Here we have plus sine sine, and so on. We have other identities like double angle identity. Here we have sine hyperbolic of 2x is 2 sine cosine, which is exactly the same as we have in the trigonometry, but we have cosine hyperbolic 2x is cosine squared plus sine squared. In the trigonometry, we have cosine squared minus sine squared. How to prove identities involving hyperbolic functions? That is the first point we need to discuss today. And the second point will be discussed today. What is the derivative of these 6 trigonometric, not trigonometric, sorry, hyperbolic functions? How to prove identities involving hyperbolic functions? The answer, always use the definition. Always use the definition. Start with the more complicated side. Try to use the definition. Try to simplify and reach the other side. For example, here, I prove some of them for you. Show that cosine hyperbolic squared minus sine hyperbolic squared is equal to 1. From this, we can gain two other identities. I will, inshallah, talk about them directly after we prove this. Of course, here the left-hand side is more complicated than the right-hand side. So what I will do here for the left-hand side, I will go to the cosine hyperbolic and replace it by its definition. What is the hyperbolic cosine of x? By definition, it is e to the power x plus e to the power minus x divided by 2. I need to square this, all of this squared, minus the hyperbolic sign of x is e to the power x minus e to the power minus x all over 2. Of course, also I need to square this. That is the first step. So what should I do now? I will simplify, expanding here. So what do we have? We have the following. طبعا over 4 because 2 square is equal to 4. Expanding the numerator, I have e to the x plus e to the power minus x all squared. So it is the first one squared, that is e to the power 2x, plus twice the first one, the second one, it will be only 2. Why? Because it is 2 times, لاحظوا, e to the power x times e to the power minus x. These two, when you add the exponents, it will be e to the power 0, and that's equal to 1. So only 2 will remain in that term. Plus the second one square is minus 2x e to the power minus 2x. I have a minus sign here, and I need to do the same for the second quantity. So this is also equal to 4. I have e to the power 2x. Now we have minus sign, minus 2, the first one, the second one. That will give me minus 2, plus the second one square is minus 2x. لاحظوا هذه الماينس multiply by the whole thing here. Okay, I'm just pointing this again. So let us simplify now. It will be e to the power 2x minus e to the power 2x. That is 0. Okay, let me write it down here. It is e to the power 2x. I will write all of them in one fraction. So this is plus 2 plus e to the power minus 2x. Okay. Then I have minus e to the power 2x plus 2 minus e to the power minus 2x, all divided by 4. And if you simplify, this will be cancelled with this. This will be cancelled with that. And you have 2 plus 2, that is 4. 4 over 4 is equal to 1. And that is exactly what we have in the right-hand side. Any question, please, about the first part? If you have any, please, you can ask questions now. Okay, no questions. Now, just look for the basic identity here. Look for the basic identity here. What happened if we divide by cosine squared hyperbolic? If I divide by hyperbolic cosine squared, راح تلاحظوا ان الكوساين سكوير over cosine square will give me 1 minus hyperbolic sine over hyperbolic cosine will give me tangent. So this will be tangent hyperbolic square of x. And 1 over hyperbolic cosine, that is secant hyperbolic squared of x. This is another identity among the list we have, and this is how to prove it. هذه واحدة منها. طبعا in the trigonometry we have 1 plus tangent square equal to secant square. You should be careful here. So I advise you always to remember this identity. Hyperbolic cosine minus hyperbolic sine is equal to 1 square, of course, squared. And then try to remember the other identities. Now, what happened if we divide by now hyperbolic sine squared? If we divide the cosine square hyperbolic by sine square, I have hyperbolic cotangent squared of x minus 1 is equal to what? 1 over hyperbolic sine, that is hyperbolic cosecant square of x. What is the advantage of remembering these identities? طبعا one of the important tasks we need to do in this section is if someone give me one of these functions, for example, I give you the hyperbolic sine and I ask you about hyperbolic cosine, then you should do it by identities only. Here we don't have triangle. We have to remember identities in order to find others from one given function. طيب نجي لسؤال آخر مثلا hyperbolic sine plus hyperbolic cosine, we need to prove that this is equal to e to the power x. Very simple, very simple. Of course, the left-hand side is more complicated, so I will start with it. What is hyperbolic sine? By definition, it is e to the power x minus e to the power minus x divided by 2 plus hyperbolic cosine, that is e to the, this is straightforward question, divided by 2. Now combining everything is over 2. And what do we have here is e to the power x minus e to the power minus x plus e to the power x plus e to the power minus x. And clearly here, the e to the power minus x will be deleted. And we have twice e to the power x over 2. That is equal to e to the power x, which is equal to the right hand side. As simple as this. Very simple identity to be proved. Okay. Now we have another identity, which is sum of two numbers, x plus y, and we are trying to find hyperbolic sine of x plus y. طبعا, as we said, always we start with the more complicated side and try to simplify. So in my opinion here, I will start with the right-hand side. It is more complicated for me. I can do some calculations there. What is hyperbolic sine of x? It is e to the power x minus e to the power minus x divided by 2. I need to multiply this by hyperbolic cosine. What is hyperbolic cosine? It is e to the power y plus e to the power minus y divided by 2. That is the first term. The second term, hyperbolic cosine of x, that is e to the power x plus e to the power minus x divided by 2, multiplied by hyperbolic sine, that is e to the power y minus e to the power minus y divided by 2. The only thing I need to do here is to simplify the expression and try to gather the similar terms together. So this is what I will do. Okay, if you allow me, I will write everything over 4. Everything here as one fraction. Everything is over 4. That is 2 by 2. Coming to the numerators we have. يلا نضرب الآن e to the x في e to the power y. That will give me what? E to the power x plus y. Okay, I will put it like this. I multiply this term by this. Okay, so that is what I have right now for the first expression. الآن e to the power x times e to the power minus y. يعني the first term by the second term. That will give me plus e to the power, I add exponents, so we have x minus y. شغلة زي كده. Okay, that's the first one. خلصنا من e to the x times the second term. Now we'll come to the minus e to the power minus x times the second, so it will be minus e to the power y minus x. عشان لا نضيع, I am multiplying this by this by that. Okay, this is what I'm doing now. So what I will have here, okay, let me just erase these arrows here. I have minus e to the power y minus x because I have minus x plus y or y minus x. Then I have minus sign. I have e to the power minus x times e to the power minus y. I add exponents. After taking the minus sign common factor, I will have here x plus y. Any question before I go to the second term? I finished the first one. I finished multiplying first two, quantities together. If you have any question, please, or I move to the second one. Plus, yalla, e to the power x times e to the power y, that will give me e to the power x plus y, that's the first one. Minus sign, e to the power, I will have here x minus y. And then I have e to the power plus y minus x. بعد كده minus e to the power minus sign common factor, I have x plus y. Actually, it is e to the power minus x times e to the power minus y, which is e to the power minus x minus y. You take the minus sign common factor and you have what you need. طيب شباب, this is equal to, لاحظوا الآن some terms will be cancelled out. Which terms will be cancelled out? I have e to the power x minus y. لاحظوا, this will cancel with e to the power x minus y with the, let us put brackets like this, and then we cancel. So this is cancelled with this. I have e to the power y minus x with a negative sign. I have e to the power y minus x with a positive sign. What else we have? We have e to the power xy plus e to the power xy. That's equal to what? That's twice the quantity, 2 times e to the power x plus y. I have also minus e to the power, so this is minus 2 times e to the power minus x plus y, all of this divided by 4. Now, if you divide the numerator and denominator by 2, you will have exactly e to the power x plus y minus e to the power, let me write it in like this, minus x plus y divided by 2. And coming back to the definition of hyperbolic functions, what does this represent? What does it represent? This is exactly hyperbolic sine of x plus y. You just use the definition, and this is exactly the left-hand side of the equality we have, or the identity we have. Any question regarding the second? Yes, please.
شكرا. The first thing when I'm trying to prove, the first thing that should come to mind is the identities.
Yeah, always you remember the definition of these functions. You need always to remember the definitions of these functions and try to do some simplification.
Okay.
Maybe someone will say, okay, it's multiple choice, so nobody will ask me to prove things. Yeah, nobody will ask you to prove. They can give you a question like this. They can give you like, the left-hand side is equal to what? Hyperbolic sine plus hyperbolic cosine equal to, and they will give you what? Will give you some choices. So we need always either to use the identities we already proved now, or you use the definition to simplify the expression given in the question. So you have the answer. Now, this is one of the basic questions that we need to, handle in hyperbolic functions. السؤال دائما, if someone give me one of these functions, how to find others? بعد كده أنا أضفت سؤال هنا cosine hyperbolic 2x, just to show you also that whenever we prove an identity, you can use it in the exam to simplify your calculation part. السؤال الأول, how to find others from the given function value here? The answer will be always we remember what? The identities. الآن I have to find hyperbolic sine, and I have what? Hyperbolic tangent. Okay, I will remember the identity for hyperbolic tangent. Myself, I will never remember all identities, لكن أتذكر دائما هذه بشكل سريع. Cosine hyperbolic square of x minus hyperbolic sine square of x equal to 1. You always remember this. طيب التانجنت شلون تحصل على التانجنت؟ I need to divide by cosine. فمعناتها identity راح تصير 1 minus hyperbolic tangent square of x equal to what? Hyperbolic secant squared of x. خلاص وضعتها هذه أمامي. I will find first hyperbolic secant, لأن مجرد أوجد الهايبربوليك secant يعني استطعت أوجد الهايبربوليك cosine. Once I have hyperbolic cosine, I can find hyperbolic what? Sine. جميل. الآن what is hyperbolic secant square of x? Secant hyperbolic squared of x is equal to 1 minus tangent hyperbolic square. That will give you 144 all over what? 169. That is 12 square over 13 squared. Jamil, this will give you what now? Secant hyperbolic squared of x equal to, طبعا if you simplify it will be 169 over 169 minus 144 over 169, that is 25 over 169. Here I need you to give me your attention, please. Because now in the exam they may give you this answer, secant hyperbolic is equal to, يمكن واحد يقول والله plus or minus radical of this, that is 5 over 13. There is something wrong here. What is it? مين يقول لي why this is wrong?
The cosine is always above 1.
أحسنت. السيكنت hyperbolic is always positive. ليش؟ لأن الكوساين always greater than 1. The cosine is always greater than 1. بمعنى هذا من يقول لي الرينج حق السيكنت شو يساوي؟ يلا نفتح سؤال جديد. الآن احنا نعرف ان الهايبربوليك cosine of x always greater than equal to 1. فقلنا من هذا ان الرينج حق الكوساين هو من 1 الى infinity، صحيح؟ لو قال لي في الاختبار find the range of hyperbolic secant، شو يكون الرينج حق الهايبربوليك secant of x؟ شو معكوس الفترة هذه من 1 to infinity؟
Negative infinity to negative 1 and from 1 to infinity.
No. It should be greater than 0, less than or equal to 1. 1 على infinity goes to 0. It will never equal to 0. 1 over 1 is equal to 1. All numbers for secant will be bounded between 0 and 1 only. It will be bounded between what? 0 and 1. واضح؟ إذا كان العدد عندك أكبر من الواحد المعكوس حقه بيكون أصغر من الواحد، لكن لأنه هو موجب فit will be always greater than or equal to 0. It will never equal to 0 because I have no number. When I divide by it, the answer will be what? The answer will be 0. جميل. يعني which answer I need to take?
Plus 5 over 13.
Yeah, I will say since hyperbolic secant of x is always greater than 0. This implies hyperbolic secant of x only is 5 over 13. الآن عندي خيارات الآن، إما أوجد الكوساين ومنها أوجد الساين، or I can directly, I have the tangent, I have the cosine, I can also find the sine from it. It's up to you. From here, I can find the hyperbolic cosine of x that is equal to 13 over 5. Now I go to the basic identity, the very important identity. Cosine hyperbolic squared of x minus hyperbolic sine squared of x is equal to 1. This implies that hyperbolic sine squared of x is equal to cosine hyperbolic squared minus 1. يعني بيصير 169 over 25 minus 1 اللي هي 25 over 25, which is equal to 144 over 25. And from here, you can say that hyperbolic sine of x is equal to plus or minus 12 over what? 12 over 5, isn't it? السؤال الآن وهذا مهم جدا. Which one I need to choose? Hyperbolic sine could be positive, could be negative. تذكروا الشكل حقها ها؟ It is always something like this. Sometimes positive, sometimes negative. Which one I need to choose? مهم هذا. The positive one or the negative one? اطلع الآن على الأعلى شوية. اطلع على الأعلى شوية. The given in the question, hyperbolic tangent positive or negative?
Positive.
خلاص مجرد يكون الهايبربوليك تانجنت بوزيتيف اكيد لازم يكون الهايبربوليك ساين از بوزيتيف. ليش؟ لان الهايبربوليك تانجنت عباره عن هايبربوليك ساين اوفر هايبربوليك كوساين والكوساين always positive. I am talking about hyperbolic cosine. So of course whenever the tangent hyperbolic is positive, for sure 100% the hyperbolic tangent is positive, the hyperbolic sine is positive, the hyperbolic cosecant is positive. واضح؟ لو كان الهايبربوليك tangent is negative, then I need to choose also the hyperbolic sine is negative. So I will write it for you here. I will say since we have hyperbolic tangent of x is greater than 0, this implies the hyperbolic sine of x also must be greater than 0. So the answer is 12 over 5, not minus 12 over 5. I hope the idea is clear for you how to find the answer for these kind of exercises. طيب, I will go to the second part. I hope I can write it somewhere here. شو نوجد الكوساين hyperbolic 2x الآن؟ يجي السؤال how to find hyperbolic cosine 2x. طبعا الجواب سهل جدا. If you remember the identity, I will write it with another color to make it clear. Now, hyperbolic cosine of 2x, hyperbolic cosine of 2x, طبعا because you are just the first time to see the identities, يعني I don't think that you remember, لكن هذه if you go back to the identities, it is hyperbolic cosine squared of x plus, احنا متعودين على minus في التراجونومتري، هنا we have plus sine hyperbolic squared of x. طبعا الجواب راح يكون everything we have cosine hyperbolic squared. We already found it, that is 169 over 25 plus hyperbolic sine squared, that is 144 over 25. Of course, the final answer will be something over 25. And then you add them, 4 plus 9, that is 13, 3 and 1, so it is 5 plus 6, that is 11, 1 and 1. So that will be, I guess, 313 over 25. That is the second part in the exercise. From where I get this, I go back to the identities we have. The identities I have is here. Okay, let me see. I think we have it here. So I get it from this identity here. Cosine 2x hyperbolic is equal to cosine hyperbolic square plus sine hyperbolic squared of x. طيب, I just mentioned something about the derivative. I think I will leave it to the next class, but I will just read them together. We will read them together and we will prove only the first one, and then I will leave the rest of the material for the next class. Derivative of hyperbolic functions. إذا احنا متذكرين trigonometric functions, this will be straightforward. The derivative of hyperbolic sine is the same as the classical one. It is hyperbolic cosine. The derivative of cosine is hyperbolic sine. Derivative of tangent is secant square. Derivative of cosecant is minus cosecant cotangent. Derivative of secant is minus secant tangent. And the derivative of cotangent is minus cosecant squared. طيب, how to remember these identities؟ احنا متذكرين حق trigonometric functions وكنا نقول whenever we have c there is a minus. Whenever we don't have c we don't have a minus. راح اقول لكم الان the first basic identities اللي هي sine, cosine, tangent, we do not have a minus. And the reciprocal ones اللي هي cosecant والsecant والcotangent, all they have a minus, and the formula is exactly the same as the formula for trigonometric functions. واضح؟ So derivative of hyperbolic sine is hyperbolic cosine, which is exactly the same as we had in trigonometric functions. نتذكرهم الدوال الأساسية ما فيها ماينس، والدوال المعكوسة هي اللي فيها ماينس ساين. كيف نثبتها الآن يا شباب هذه؟ Very simple. I go back to the definition. فراح أجي هنا d by dx. What is the definition of hyperbolic sine? The definition of hyperbolic sine is e to the x minus e to the power minus x over 2. And the derivative of this is just, this is constant. I don't care about it. Derivative of e to the x is e to the x. The derivative of e to the power minus x is e to the power minus x times a minus. فراح يعطيني هنا plus e to the power minus x. And this is exactly what do we have as hyperbolic cosine of x. And how to prove hyperbolic tangent? The left-hand side is equal to, quickly, this is equal to derivative d by dx of hyperbolic sine of x divided by hyperbolic cosine of x. And the answer will be derivative of sine is hyperbolic cosine of x multiplied by the second one. So that is cosine squared minus the first one is hyperbolic sine of x. Derivative of hyperbolic cosine is again sine hyperbolic. So this is squared over hyperbolic cosine squared. That is hyperbolic cosine squared of x. طبعا if you simplify using the identities, we know that hyperbolic cosine squared minus hyperbolic sine squared is equal to 1. So it is 1 over hyperbolic cosine squared of x. And using the reciprocal identity, 1 over hyperbolic cosine is secant. So this is nothing but secant squared hyperbolic of x, or hyperbolic secant squared of x, which is the right hand side. I think that's enough for today's class. Inshallah, we'll continue proving the last one, which is hyperbolic secant, and then we will see how to use these identities or formulas for derivative to find the derivative of hyperbolic functions. Now your quiz is in the Blackboard. You just go to the Blackboard, go to assessments and tests, and you can see your quiz there. So I will stop now recording, and then, okay, this is what we have. طيب.